Hello students, today we are going to start with the new topic, that is types of extrinsic semiconductor. We have learned that semiconductors are of two types, that are intrinsic semiconductors, that is pure semiconductors, and extrinsic semiconductors. Here we can say impurities added to the pure semiconductor, then that type of the semiconductors are called the extrinsic semiconductor. Now this extrinsic semiconductor further we can say classified as n type and p type semiconductor. Let us study one by one. In n type semiconductor, there are increased number of electrons in the conduction band. More number of the we can say electrons are present in the conduction band. So these semiconductors are there, n type semiconductors are there. They are obtained by adding group 15 element to the intrinsic semiconductor, which belongs to group 14 element. So we can say here group 15 element is added to the group 14 element, and then we get the n type semiconductor. Consider the example, the doping of silicon, which belongs to 14 group, with the phosphorus belongs to 15 group. Silicon has crystal structure in which each silicon is linked tetrahedrally to 4 other silicon atoms. When small quantity of phosphorus is added to pure silicon, the phosphorus atom occupy some vacant sites in the lattice of silicon, and then you can see the structure of the we can say this crystal lattice of silicon, where one of the position of the silicon is occupied by the phosphorus. So we can say the phosphorus atom occupying the regular site of the silicon atom in the figure. Now if you look at the we can say figure, the 4 out of 5 electrons of the phosphorus, they are we can say that the link with the 3 silicon atoms. One, you can just see the figure one, the out of these 5 valence electron, 4 electrons are there of the 4 electrons of the phosphorus, they are linked with the we can say the 4 silicon atom, and the fifth extra electron is there, they remain as it is, and then it goes to the we can say conduction band, and this fifth electron we can say that the conduct electricity. So here we can say if you take pure silicon atom, it has the low conductivity, but if it is doped with the phosphorus, it shows the more conductivity. So this is the we can say that the example of the n type semiconductor. Now after seeing the n type semiconductor, let us see now the p type semiconductor. A p-type semiconductor is produced by doping a pure semiconductor material, maybe silicon or germanium, with an impurity of group 13 element. Means here the semiconductor of we can say that the silicon or germanium, we can say it belongs to the group 14, and it is we can say that the mix the impurity is there, that is dopant is there, that is the group 13 element. These elements contain less number of valence electrons than that of pure semiconductor. Means group 13 elements are there, they contain less number of valence electrons than the we can say silicon or germanium. Then if you see, that means when the we can say that the pure silicon doped with the boron atoms occupy normal position of some of the silicon atoms in the lattice. You can see in the figure 1, the boron atom occupy the position of the regular we can say phosphorus one, the silicon one. Then The boron atom has only 3 valence electrons. It does not have enough electron to form bond with its 4 silicon neighbor. So you can see in the figure, it can form bond with the, we can say, 3 silicon atom, and not the, because of the less number of electron, it cannot form the bond with the fourth, we can say, silicon atom. So boron atom forms bonds with the 3 silicon atoms, and the missing fourth electron creates electron vacancy, and that electron vacancy is called as hole. So you can see, here the hole is created. Hole means here we can say there is a vacancy of the electron is not there, so boron cannot form the bond with the, we can say, the silicon atom one. Then a hole has tendency to accept electron from its close vicinity. Thus a hole behaves as if it has a positive charge. Means we can say the, it's like a positive charge. Nearby electron comes that are accepted by the, we can say, this hole. The electrons in the partially filled valence band move under the influence of applied potential. Means when the potential difference is applied, that time the valence band is there, which is partially filled one, which are partially filled with the electron. It is, these electrons are there, they move under the influence of this, we can say, applied potential, and the holes move in the opposite direction. So we can say here the holes and electrons, they move in opposite direction under the influence of applied potential. Now remember, whether a material is, whether we can say, extrinsic or intrinsic, whether the semiconductor is intrinsic or extrinsic, these materials are always electrically neutral. An n-type semiconductor, such as silicon doped with the phosphorus, has more electrons than those needed in the bonding, and thus has the, we can say, that the electrons in the partially filled conduction band. In the p-type semiconductor one, such as we can say the silicon doped with the boron atom, the boron atom has less electrons than needed for bonding. Thus it has vacancies, that is holes in the valence band. So students, go through the video and write the notes on the p-type semiconductor, n-type semiconductor, or we can write the types of the, we can say, extrinsic semiconductor. Okay, thank you.